In this video, we are going to talk about the parts of a parabola when we're looking at it in factored form. And if we want to consider factored form kind of in the most general way, we see that we have two factored form equations right here, but what we'll often write is something like y equals a times x minus m and x minus n. And that's one of the ways that we will often write a factored form. Um, and sometimes you'll see it where we use P and Q in here, but we just use different variables to identify that these two things are the values that we would find along here. So let's see. So let's talk about the different parts that we can find here. So instead of using this general notation, I'm going to look at these two specific ones, and we're going to see where these different values fall on our graph. So first thing that I notice is that this one is opening up. So this is a positive quadratic. And over here on the right, we have a negative quadratic. And the one thing that I notice is that this is a negative value and this is a positive value. So this a value here, if we consider this a value here, if a is positive, then you're going to have a positive quadratic. So basically, if you're going to have a positive, then it's going to be red. So maybe we just make this red. Here we go. How do we do that? There we go. We make this thing red. So if A is positive, it's going to be red. And if A is negative, then we're going to have a negative parabola. Additionally, I notice a couple things here. I notice that when I'm looking at this, that I see here, I've got a 0 or an x-intercept at 2, and here I've got a negative 2. And then over here, I see that I've got a negative 4, and here I've got a positive 4. So that's kind of interesting, but I can see that my zeros, my x-intercepts, are within the factored form. And we could probably see over on the blue equation, or the blue graph, that here, again, that if we're looking at this positive 1, there seems to be a negative 1 right here. So maybe this one corresponds with this thing, it seems to be. And then we can also look over here that it looks like this positive 5, and we've got a negative 5 right there. So it also seems as though the zeros are within the factored form, and that the zeros are opposite of how they're written in the factored form. The opposite, let's say the opposite value. And we're going to get into more of this in another video, but they are the opposite value of how they are stated. In the factored form. So it appears that if we are seeing a negative 2 or a negative value, that it would appear over here on the positive side. And if we're seeing a positive 4, then we're seeing this over here on a negative 4. And same here, a positive 1, we've got a negative 1, a positive 5, we have a negative 5 for our zeros. Additionally, just like we talked about in one of the other videos, we've got the axis of symmetry, which is running right through the middle of these graphs. So there's our axis of symmetry. The axis of symmetry. And let's see if we can find some connection with the axis of symmetry. So, well, the axis of symmetry, we know that it's going to be in the middle, so that this thing, if I folded this side over, it would match up here, and vice versa. If I folded this, it would match up on this side. And similarly, if I folded this side over, then it would match up on this side. But it's right in the middle of these two things. So if I can find the center of these two values, then I should be able to find that axis of symmetry. And one way to find the center of those is to find the average. So over here on the right, if I take -5 plus a -1, and I divide that by 2, then that's going to be -6 divided by 2, which is -3. And if I look here, I see my axis of symmetry is on the line x equals -3. And similarly, over here, if I take -4 plus a +2, plus 2 divided by 2, that's going to be -2 divided by 2, which is -1. Let's get that negative in there. That's going to be -1. And so we have here our axis of symmetry is the line x equals -1. Now, if I wanted to find where the y value is, the vertex, again, here's our vertex right here. That's our vertex. And here's our vertex right here. It's our vertex. So if I wanted to find that, I take my axis of symmetry, and if I were to drop it in from my x's right here, that would calculate the value of the y of my vertex. And similarly, over here, if I took this -3 and I dropped it into this equation, I would get the y value for right here. Let's do the one on the right. Let's do the red one and just double check that. So if I've got y equals, so this is saying I'm looking for y when x is equal to -1. So y equals 1/2 -1 plus 4 times -1 minus 2. All right, so y equals 1/2 times 3 times -3. Y equals 1/2 times -6. So what is the value of, is that, no, sorry, not -6. 1/2 times the value of -9. So therefore y would equal -4.5. And if we look right here, we can see that this goes down to -4.5. So our vertex is the value of -1, -4.5. So that -1, again, coming from our axis of symmetry, the -4.5 coming from dropping that axis of symmetry into our equation and solving to find out what the y value is. What is it going to be over here? Well, we can see that it's going to be a +2, but if you were to go through the calculation, you would also see that that would come out to be a +2. So there are 3 or 4 different parts of the parabola from our factored form.